One of the biggest ideas in behavioral neuroscience is the idea that the brain produces behavior, and that behind every behavior there's corresponding physical activity in the brain as well as molecular mechanisms that drive that physical activity. And for me, the most interesting behaviors of all are learning and memory behaviors, because it's not just how you walk and how you talk, but it's directly related to your very identity. It's what you know how to do, and therefore it's who you are. Now, the physical activity in the brain that corresponds with learning and memory behaviors largely happens in a place called the hippocampus. And the molecular mechanism that drives hippocampal activity is called the N-methyl deaspartate, or NMDA receptor, which is a receptor located at the connections between neurons. Now, as the phrase learning and memory implies, they're two separate behaviors, and correspondingly, there are two separate processes that happens in neurons. There's a learning process that induces physical changes in the very structure of the neurons themselves, and then there's what's called a consolidation process, which is where you take what you just learned and you solidify it into permanent long-term memory for future use. If you don't consolidate what you've learned, that's called forgetting. Now, what I want to know is, what role do NMDA receptors have in learning and memory? Is it the learning phase, or is it in the consolidation of what you just learned? And so to answer this question, what I plan on doing is taking some rats and training them in what's called the Morris water task, pictured here. And basically what it is, it's this big pool of water, and underneath the surface of this water is a hidden platform that the rats can't see. And when you put the rats in, initially they do what you see on the left, which is they have no idea what they're doing. And after multiple trials, over multiple days, they will do what you see on the right, which is they will learn and remember where the platform is located in the maze, so that when you put them in, they will swim directly to it. Then, once they've acquired that position memory, I'm going to inject what's called an NMDA receptor blocker, which prevents NMDA receptor function, directly into the hippocampus of these rats, and I'm going to retrain them to a new position on the maze, all within the course of about 2 hours. Then, 24 hours later, I'll take away the platform from the pool, and I'll put the rats back in, and I'll ask the question, where do they swim to? The original platform location or the new platform location? Now, the results of this type of study are really showcase the elegance of the design. So let's say NMDA receptors are involved in learning processes. Well, when you put the blocker into their brain and you test them, they won't learn anything. They'll do what you see on the left. But if NMDA receptors are, let's say, involved in consolidation processes, then they will learn the new position, and when you test them 24 hours later, they won't go directly to the new position. They'll go directly to the original position, because even though they learnt it, they have no memory that the new position they learned even exists anymore. And so after just recently completing the first iteration of the study, that's exactly what happened. And so with this type of research, I hope to end a decades-long debate about what NMDA receptors actually do in the rat hippocampus regarding learning and memory, and also outline the molecular basis of how we learn, how we remember, and how we forget, and how that makes us who we are. Thank you very much.